This video shows the use of simulation for inventory problem. The example I will use is the Simkins hardware store.
Simkin hardware store wants to find an inventory policy for one product, the electric drill. The store wants to know what quantity they should order to minimize the total cost.
The store examines its records and got the following data. So the first data is about the demand. There are 15 days when demand is 0, 30 days when demand is 1, and so on. Altogether there are 300 days. The next data is about the lead time, which represents the time from when the order is placed until the order arrives. So there are 10 orders when the lead time is 1 day, 25 orders when the time is 2 days, and so on. We have to add 3 more columns: the probability, cumulative probability, and the random number interval. So let's say for demand, when demand is 0, the probability is 15 over 300, which is 0.05. Then 30 over 300, 0.10. Continue. And one way to check the answer is, if we add the total, it must be 1. Next, we find the cumulative probability. We add the probability. So we start with 0.05 plus 0.1, 0.15 plus 0.2, 0.35, 0.75, 0.90, and 1.0. The last number must be 1. Then we get the random number interval. We start with 0, 1 until use the cumulative probability, so 0, 5. So 0, 5. After 0, 5 is 0, 6 to 15, 16 to 35, 91 to 0, 0. We do the same for the lead time. The probability lead time is 1 is 10 over 50 or 0.20. 25 over 50 is 0.50 and 0.30. So the total must be 1. Then the cumulative probability 0.20 plus 0.5, 0.7 plus 1.0. Then the random number interval start with 0, 1 to 20, 21 to 70, 71 to 0, 0. The important columns are the first column and the last column. Because the space on my whiteboard is limited, I will remove the columns I don't need. Similarly, for the table for the lead time, I remove the middle columns. So these are the tables we need to use to carry out the simulation. The next step is we have to find the subheadings for the simulation. To get the subheading, we have to understand what happens when the store sells the drills from day to day.
On day 1, the store opens for business in the morning. The number of drills the store has is the beginning inventory. If there are customers who want to buy the drills, there is a demand. The store then sells the drills. In the evening, the store closes the shop. The number of drills left is the ending inventory. The owner then conducts a stock check for the drills. If the number is above the reorder point, the owner does not order for additional drills. But if the number is at reorder point or below, the owner then orders additional drills. On day 2, the store opens for business again in the morning. The beginning inventory is the same as the ending inventory from the previous day. The store then sells the drills according to the demands from the customers. In the evening of day 2, the store closes the shop. The owner then conducts a stock check. If the ending inventory is at reorder point or below, then the owner orders additional drills.
These are the headings for the simulation. The first is the day. Units received refers to the amount of items received when an order is placed. Beginning inventory is the amount of items at the start of the business day. We also want to know the demand, how many items the customers want to buy. But if you want to know the demand, we have to use this table. We have to use the random number first. At the end of the day, the amount of item is the ending inventory. We also want to know whether there is any lost sale. This refers to if a customer wants to buy an item but it is not in stock. The ending inventory also determines whether the owner should order or not. If it is more than the reorder point, then the owner should not order. But if it is at reorder point or below, then the owner should order. Now, if the owner orders, then there is the lead time for the order. It can either be 1, 2 or 3. So if you want to know what is the lead time, we have to use the random number. Before we conduct the simulation, we have to make several assumptions. We assume every time we order, the amount we order Q is 10. The reorder point is 5. The beginning inventory is 10. We also get some numbers from the random number table. Now, these are the random numbers. The owner wants to do a simulation for 8 days. On day 1, the owner didn't order anything. So units received is 0. Beginning inventory is 10. First random number is 33. For this demand table, 33 is between 16 to 35. So demand is 2. So the inventory is 10 minus 2 is 8. Now these two customers, they are able to buy the drills. So lost sale is 0. And inventory 8 is more than the other 0.5. So the owner does not order. So we don't use this part here. Day 2, there is still no order, so unit received is 0. The beginning inventory is the same as the previous day's ending inventory, which is 8. So after 33 is 82. So demand is 4. Inventory 8 minus 4 is 4. Lost sale 0. Now 4 is less than the order 0.5, so the owner has to order. I'll go to this part. So after 82 is 68. So we use this lead time table. 68 is between 21 to 70. So lead time is 2 days. On day 2, the owner has to order. But the owner does not order on day 2. The owner orders on the next day, day 3. Now the lead time is 2 days. That means the order arrives 2 days later. So if order on day 3, the order arrives 1, 2. So on day 5. Now the amount of the order is 10. So here is 10. Now go back to day 3. Unit received is 0. Beginning inventory is 4. Next, and the number is 50. So demand is 3. Inventory for 1. Lost sale 0. Now, inventory 1 is less than the order point 5. But another requirement is the owner has to wait until the previous order has arrived. Then only the owner orders again. So the previous order has not arrived yet. So the owner does not order. So no. This one unit save still 0. 1. So after 50 it's 22. 1, 2. Okay. So beginning inventory is 1, demand is 2. So ending inventory is 0. But there are 2 customers who wants to buy, but there's only 1 drill. So that means 1 customer cannot buy. So lost sale is 1. Now the previous order has not arrived yet, so order is no. Day 5, now the order arrived. which is 10. So beginning inventory now is 10. So after 22 is 27. Demand is 2. This one is 8. Lost sale 0. Now 8 is more than the other point, so order no. On day 6, unit received is 0 because there is no order, and the beginning inventory is 8. So next random number is 08. So demand is 1. And the inventory 7. Lost sale 0. Now 7 is more than the other point, so do not order. Next day, the inventory is 7. The 08 is 84. Demand 4. And inventory 3. Lost sale 0. Now 3 is less than the other point 5, so yes, order. So next number is 02, which means lead time is 1 day. So that means the owner orders the next day, day 8, but the item arrives the next day, 1 day later, but that is day 9, which is outside the day of our simulation. So we don't write the number units received. So next, continue. This one is 3. After that is 19. So demand 2. Inventory is 1. Lost sale 0. Now the previous order hasn't arrived, so no, we will order. So we finish our solution because we have reached day 8. We want to conduct a cost analysis for this solution. Suppose ordering cost is $10 per order, holding cost is 3 cents per unit, and the shortage cost is $8 for each lost sale. So for this simulation, the ordering cost. So here we order 1 and 2. So we order 2 times. Each order costs 10. So 2 times 10 is 20. Then the holding cost. This refers to the ending inventory. So the total inventory is 8 plus 4, 12, 13, 21, 28, 31, 32. It is 32 times the holding cost is 3 cents per unit. So times 0.03, 0.96. Then the shortage cost. This refers to the lost sale. So the total lost sale is 1. So each lost sale, the cost is 8. So it is 8. So the total cost is 28.96. The aim of any inventory policy is to minimize the total cost. So the question is this the minimum or the optimal cost? Actually we don't know. We only know this is the cost when we use Q equals to 10, the order point is 5. So what we should do is we should try other values. So instead of Q equals to 10, maybe try Q equals to 15. Or maybe instead of 0.5, maybe use 8. See what happens to the total cost. Does it increase or decrease? So this is one disadvantage of simulation. Simulation does not give the optimal solution. What we have to do is we have to try many situations. So that is what is considered as what if cases. But of course, if you want to do it manually, it's difficult. So usually we do this solution using Microsoft Excel. So we can try many values and we get the total cost very easily.